Hello everyone. In this video, I will try to provide an answer to an interesting question one of you posted on Piazza. So, feel free to pause the video right now and read and understand this question. Alright, so as you can see, this is an interesting question, and it actually can be restated into a following question. What velocity field we have in the rope? Okay, as you can see, I copied this picture here, and this rope, can be divided into three chunks. First chunk will be from point D, so this point, let's say to this point, to point Q. So it will be this chunk. Second chunk of the rope will be from point R to point S. So it will be this chunk. And third point will be between points Q and R, here. Okay, so let's call it chunk number 1. Okay, this will be chunk number 3, and this will be chunk number 2. So when it comes to chunk number 1, so from point D to point Q, each and every point on that rope has velocity v star. Velocity of each point of the rope is v star, basically. V star, and in this case, this is 10 feet per second. When it comes to chunk number 3, so from R to S, velocity, that chunk is stationary, right? That rope does not do anything. So velocity of each point will be 0. Okay, and something interesting happens between point Q and R. In here, these points of the rope have different velocities. Let me illustrate it on this picture. But before I illustrate it, I just would like to draw a plot. So in here we will have basically length, length of the rope, and here we will have velocity. So from point D to point Q, our velocity is constant, and it has 10 feet per second. Then, from point R to point S, our velocity is 0. And between these 2 points, something happens. And the rest of the video will be dedicated to figuring out what's happening there. So let me maybe copy this drawing here. Maybe I want to make it even larger. Okay. So as I said earlier, this rope has velocity 0. That means that in particular, point R, excuse me for that, point R, so velocity of point R is also 0. Yes? Then we also said that velocity of point Q is v star, right? Which is equal to 10 feet per second. Okay, now the question is, what is, for example, velocity of this point that is between points Q and R? If we would like to find this velocity, we should go for, so let's call that point T. Why not? Velocity T. So if we would like to find velocity of point T, we should go for this expression. Vt is equal to Vr plus omega of this disk times RTR, where RTR is of course here. Oh, excuse me for that. This is our RTR. Okay, and I believe that omega rotates this way. Okay, so you can clearly see that our velocity of this point, of point T, will be perpendicular to this vector. So this is our velocity T. And we can obtain each and every velocity of this chunk of the rope if we follow this expression. This will be some trigonometric function, so speed of T will be just some trigonometric function. Rig function that starts at 0 and ends at 10. So Vt belongs to 0, 10 feet per second. Okay, so let's draw this function here. It will be something like that. And this is velocity in chunk number 1, chunk number 2, and chunk number 3. Okay, so this is the answer to the question posted on Piazza. This is how velocity field in the rope looks like. Thank you for your attention, and I hope that this answer was clear and helpful. Thank you.